When we first built Semantic Kernel, we wanted to fill a gap we saw in the market, providing an enterprise-grade SDK for AI. What that meant for us is supporting .NET devs first, making sure that they didn't feel left behind by the rest of the industry. As we worked with these enterprise app devs, we learned so much by just listening, by providing features like dependency injection, hooks for responsible AI, having minimal dependencies, and of course, observability, telemetry. But that's not the only thing that we learned. We learned that development doesn't happen in a silo. Yes, app devs build the applications and scale them out, but in most companies, there's pockets of AI and ML researchers that are at the forefront, figuring out what's possible, building those POCs. And today, those two different teams don't really work together. There's this chasm, this gap between the two, a gap that we in Semantic Kernel wanted to solve. Now, the reason we thought it was so important for these two teams to work together is that by together, they could achieve so much more. Your AI devs are looking into the future, trying the latest models, the newest patterns, figuring out how to keep their company relevant into the future with AI. Your enterprise app developers, they're keeping the lights on. They're building enterprise applications that are scalable, reliable, performant, secure. They're maintaining that trust with your customers. And together, they can unify, combine those skills that they've honed over years or decades. Skills that are frankly impossible to acquire over a night or a weekend. You need to have these different teams working together. The challenge, of course, is that they're using different tools. They speak different languages. Python is the language of ML and AI devs, where they're trying the latest patterns. They're quickly building those POCs. Enterprise app devs are using .NET or Java. And what we want to do at Microsoft is not have to ask these different developers to learn completely new tools or different languages. You should be able to feel comfortable and confident in what you already know today. But there needs to be a bridge. There needs to be a way for these different developers to not have to move to the other side, but at least visit, to talk, to work together as one. And at Microsoft, that bridge is Semantic Kernel. Now, last week was a huge milestone for Semantic Kernel. It was Microsoft Build, where we announced Logic App support, so you can bring any Logic app as a plugin into Semantic Kernel. We launched hooks and filters, which allows you to practice responsible AI and semantic caching within your apps. And my personal favorite, we now support Azure Container Apps dynamic sessions, which allows you to recreate the code interpreter experience of the Assistants API. But most importantly, we announced V1 support for Python and Java. This means that all of our SDKs, Python, .NET, Java, are all V1 plus. This means no more breaking changes, so you can build an app today and years from now not have to take a major refactor update. I know no other AI SDK that has committed to V1, that has committed to not having any more breaking changes. This also means that if all of your teams use Semantic Kernel, they can align on concepts. You don't have to argue about what is a plugin, what is an agent. We have those definitions. You can use them across your company so that you can spend less time on semantic conversations and more time developing solutions for your customers. But most importantly, going back to that bridge metaphor, as part of V1, we ensured that all of the inputs, your prompts, your plugins, behaved identically across all of these different SDKs. And that's huge. What that means is each of your different divisions can write some fairly minimal semantic kernel code and then import those resources from other divisions, no matter what language they're using. Most probably, your Python devs, your AI researchers are going to build out those POCs, figure out what works and what doesn't. And once they do, instead of figuring out how to deal with live sites or telemetry or making their Python applications performant and scalable, All they have to do is take those assets and give it to their app developers. They're not asking them to refactor everything. It's, hey, here's some files. This is huge. And to show you just how easy it is to start with Python and graduate into .NET and Java, I'm going to be showing you how to build an application with these new resources and then bringing them into those other enterprise languages. So let's go ahead and take a look at my screen. As a Python AI researcher, I'm in my happy place. You can see I'm using the V1 version of Semantic Kernel, so I can create a kernel. I can add in AI services like Azure OpenAI or OpenAI, but any AI service will do, whether it's Mistral, Llama, even Gemini, it doesn't matter. In a bit, we'll be adding in plugins. We'll be talking about them, but this is where the magic actually happens. This is where we send all of your existing messages to the AI, to the LLM, so that it can come back with the messages for the user. Everything else is non-semantic kernel code. You're loading in messages from MongoDB, I'm printing things to my UI, and then I'm saving things back to MongoDB. And so with just a minimal amount of code from semantic kernel, we can start creating an agent that I can talk to. So if we come to our little UI here, I can say hello, say hi back. But what if we actually wanted the AI to do something productive, real? In the studio today, I have some lights. I, of course, have some speakers on my computer. What I'd like to do is throw a party, a celebration for our V1 of Python and Java. So let's actually ask the AI, please turn on the lamp. Now, its response should be pretty predictable. It can't do that. It's just an LLM. So the next question is, how can we give it the ability to turn on this light bulb? Well, the answer are plugins. In semantic kernel, plugins are the ability for you to give native code, APIs, any sort of logic to the AI so that it can invoke it and call it. Now, I love this demo because it gives me an opportunity to show a Swagger file, which for most of you, this should be very familiar because this is the way to build and deploy and share APIs within your company, within your enterprise company. This particular Swagger file gives me everything I need to actually turn on this light bulb. Get the lights, get information about the lights, change the state of the light. And what's also great about the Swagger file is it has everything that the AI needs in order to call it. A description, the inputs, the outputs, all of the same information that you've been providing to humans so that they know how to use the API is the exact same information that you can now provide the LLM. If you aren't using semantic kernel, you'd have to write hundreds and hundreds of lines of code actually taking this information and bringing it to the AI. But with semantic kernel, it's as simple as this. We're adding a plugin from OpenAPI. We're providing a Swagger file, and then you can set up some optional configurations if you really want to. So let's go ahead and save this. And now we'll ask, please turn on the lamp. And this time, because it has the plugins, we have our light turned on. That's huge. That means your AIs can actually manipulate and do things in the real world. I'm turning on a light here, but you can imagine sending an email, approving something, right? Real work, productivity. That's what AI should be about. Now, I'm not done. If I want to throw a party, a harsh white light is just not going to do it, right? And I have some other lights on the stage that we might as well ask them to turn on. Turn on the rest of the lights. But again, they're kind of harsh. What we want to be able to do is actually set the mood. Do something kind of chill or something inspired by Microsoft Build. So this is where I'm going to be building something with retrieval augmented generation, or RAG for short. What that basically means is you're retrieving information from some external source and you're using it to augment what the AI can do. In this case, I want to build a service, a search service, that will retrieve for me a bunch of colors for these lights so that the AI can actually set them to the right colors. So again, we're coming back to my screen. I'm an AI researcher. I want to build another Flask app. Here I have a scene endpoint, and to get some colors, I'm generating an image based on a prompt, and then I'm getting its top colors before returning it back to the user. Because it's a Flask app, it's super easy for me to build an open API spec where I can then have a UI to actually test and try it out. Here, I can provide a description. I'm using Microsoft Build and some recommended colors. So I can go ahead and execute it and get some colors back. What I hope you notice though is this is kind of slow, especially if we're waiting all this time just to get an image that looks like this. Nothing too exciting here, right? But all we need is the color, so it doesn't have to have the highest quality. But if you're having a back and forth chat, having that latency is frankly unacceptable. And so this is kind of a common problem with RAG. How do you actually get information for the AI as quickly as possible? And in the AI space, what has been developed is something called memory, powered by vector DBs. That's a lot of words. What's probably more familiar to you as an application developer is caching. What we're going to be doing is retrieving results from our cache and saving it once we get new content, in this case, colors. What's different with vector DBs and memory and semantic caching is that instead of having to require a specific ID to get the cache back, now we can provide a semantic description. So if I come back here and I have Microsoft Build, I could change this up. It's different. It's a different string, but semantically, it's still the same. And so this time, I didn't have to wait. I'm getting the exact same result back that I did before. So we've gone ahead, built our retrieval service. Now, to actually use it, of course, we'll want to add a plugin. So we're just adding in that Swagger file. What I'd like to do is go ahead and add one more plugin, the speaker plugin, so that the AI can go ahead and play some music. Now, if we come back to our experience, we can go ahead and ask it now, please play Python.wave, but first set the mood with the lights. Now I love this one query because I'm asking it to do some fairly complicated stuff. It first has to use our scene plugin to get colors to set the lights, then of course set the lights that we see back there, and then it plays some music. This is the way you can use plugins, give it to the AI, and the AI creates a plan. So for all of you out there that have enterprise scenarios where you have to coordinate multiple things, orchestrate activity, before you would have to build out all these different flows, build out UIs. Now you can just give an AI plugins and it can figure out the right order to call your functions. Now at this point, we've already had some fun. We've changed the lights. We've gotten her that really fun Python song, which my husband created using some AI tools. But now what we want to go ahead and do is see what it's like to reuse these exact same plugins in Java, another enterprise language. So to do that, let's go ahead and go to our Java equivalent. And we should start seeing very similar stuff what we had in Python. We are adding a bunch of services, creating our plugins. We create our kernel down here. And we have the same sort of experience where we're loading and saving things from MongoDB. So I can actually reuse this chat. So I'll go ahead and come up here and change it to Java. And now we're going to ask it the exact same request, but instead of playing some Python music, let's play some Java music. Let's go ahead and ask it, please play java.wave, but first set the mood with the lights. So once again, it's calling that scene API. It's going to call the light APIs and play some music. And the way it did this is, again, it used those exact same resources. When I first thought of coming up with this demo, I thought I would have to copy and paste a bunch of resources. But I didn't. I could just point to either the version on the web, or if you want some stronger control over things, what I've done is I've actually created a folder called plugin resources, and I have all of the plugins that we've used so far, the light plugin, the scene plugin, the speaker plugin. And we can see all of the semantic descriptions that allows the AI to choose the right tool. What can happen is the AI researchers are the ones that come in here and refine and refine those descriptions, figure out what makes the AI pick the right function. And once they're done, they can check it into GitHub. They can run GitHub actions to run evaluations to test that there are no regressions. And then once it's fully merged in, your enterprise devs, like the Java dev that we just saw, can use it instantly. Now for my last bit of the demo, what I love to do is show .NET, one of my favorite languages. But we're going to do a little bit more than just change the lights and play some recording music. We're going to actually synchronize the lights. And to do that, we're going to use my favorite feature from Microsoft Build, Azure Container Apps Dynamic Sessions. And if we come to our code, we can actually see we're using dependency injection to get our wrapper implementation around ACA dynamic sessions. In this case, I'm calling it Python Planner. And then I can use dependency injection when I build my kernel to actually add all those plugins, including those from those OpenAPI Swagger files. Now, before I jump into actually using this plugin to actually synchronize the lights to the music, what I'd love to do is actually show you what it was like working with the AI to come up with this final script that it's going to execute. At the top here, we can see I was talking the day before my session at Microsoft Build. Hey, how can you help me? We had this conversation, but then we started actually working on code together. But instead of the AI just giving me code that I executed and tested, it did the testing itself. We can see this kind of chain of just AI messages. It came up with some code, it ran into some issues, it tried running it again, and it did that until it got to a point where it actually had working code. And so to simulate that same experience, what I'm going to be doing is I'm going to paste in some code in a bit to the AI that has a bug. Y'all watch it get fixed, and then we're going to see a nice light show on top of a video that we prepared just for Microsoft Build. Alrighty. So what we're going to do is paste in the code and see what happens. And there, it looks like there was some sort of issue, so it's going to try to get that fixed. It's going to run it again. It looks like there was one more issue. Let's fingers crossed it gets it right this time. You know what? It's probably best that I get out of the way.
Hi, I'm Tristan Watkins, Head of Service Architecture at Advania UK.
Hello, I am Jose Luis Latorre, a software engineer.
Hi there, I am TJ, a developer at Nextflow.
Hi, my name is Darius. I am AI developer.
Hi, my name is Saad. I'm a solutions architect and a product lead.
Hey guys, I'm Jorge Tucali, DX Head of Engineering at Expand IT.
Hey, my name is Alex Chen. I'm a senior consultant.
This is Kirtana, and I'm a senior data consultant.
Hi there, I'm Rodrigo. I've been working with Semantic Kernel, I guess, like from the very beginning, around March last year.
I cannot say enough about Semantic Kernel. It helped us get our product to market months ahead of schedule. I'm not sure what we would have done without it.
Semantic Kernel is a powerful SDK that takes away the pain of setting up different API layers for different AI models from you.
Overall, it's just helping us organize our projects better and deploying Gen AI at a better responsive rate.
As a .NET developer, it's really the framework that you would choose to build on because it's really the only one that gives it first-class support. As a more Python-oriented person myself, it's also really good to be able to kind of reference the same framework that the .NET devs are building on and kind of work together in that way.
Semantic Kernel has been very helpful for us. We have developed a Copilot app that enables our operational staff to swiftly address urgent situations, reducing the time needed from hours before to just minutes now.
One of the things I absolutely love about Semantic Kernel is its architecture. It allows you to easily develop plugins that can be used in your own apps or in Microsoft's Copilot ecosystem. This modularity is my favorite thing about it.
We can target several types of large language models, even small language models. We utilize pretty much everything in the SDK. Plugin development, planners, RAG.
What I truly love about it, it's its revolutionary approach. It's not just technology, it's a paradigm shift, enhancing our applications.
The thing I love the most about using Semantic Kernel is the ability to break down the functionalities that we need into specific modules and tackle them separately. We can then focus on those specific modules and iterate them rather quickly in order to build more complex apps.
Semantic kernel is always a foundation for our application. We start simple, and then when application grows, we can add new components to it.
Semantic kernel clearly stands out to be a key enabler in this realm, helping us build sophisticated and complex AI solutions, allowing our teams to concentrate on improving our business process, workflows, and productivity with AI, rather than trying to reinvent the whole wheel of building the foundational AI orchestration capabilities from scratch.
For me, Semantic Kernel is the keystone that connects LLMs with other APIs and AI capabilities, and I really hope it's the same for you. Thanks, everyone. Bye.
Thanks, Semantic Kernel team, and I can't wait to see where the SDK goes from here. Thanks.
And that was super cool. I hope that inspired you to build your own applications in Semantic Kernel. I hope that it showed you that you don't have to work alone. You can work now with your AI teams. If you're an AI researcher, you can work with your app development teams. Y'all can achieve so much more together with Semantic Kernel. I can't wait for Build next year. We have a really exciting summer that's coming. Expect a roadmap video in a couple weeks where we're sharing what comes next for Semantic Kernel. Thank you.